This is the first video of the channel in Discrete Math. The first chapter is called the Foundations, Logic, and Proofs. And in this chapter, there'll be, I believe, 8 videos, 1.1 through 1.8. 1.1 is Propositional Logic. Sorry for my handwriting. Logic. 1.2 is Applications of Propositional Logic. I don't know if we'll cover this one. 1.3 is Propositional Equivalences. 1.4 is, today we're doing this one, by the way, so keep watching the video if you want to see that. 1.4 is Predicates and Quantifiers. 1.5 is Nested Quantifiers. 1.6 is Rules of Inference. 1.7 is Intro to Proofs. We go over the types of proofs. And 1.8 is some more proof methods and strategy. Okay, now that's kind of what we're going to focus on within the first 8 videos. So let's go to 1.1. This is called Propositional Logic, Discrete Math. That's the type of math we're learning. Okay, so in Discrete Math, there's these. You start out by learning these statements, and a proposition is a statement that is either true or false. So you can say, example, the capital of North Carolina is Raleigh. Is that true? Yes, that's true. So that statement could either be true or false. So that would be the answer to that. We write eventually in these next few sections, we'll basically say P is equal to the capital, and we would write this statement out. Sorry, I didn't mean to go to that statement out right here. And we can say, like, is P true? And we would say, or is P, or what is the, sorry, like, what is the truth value of P? And we would say true. So a proposition is a statement that is either true or false. The statement, for example, the capital of North Carolina is Raleigh, which is true. These P things right here, it can be either P, Q, R, S. That's what normal variables they use. And these statements are, these are proposition variables. All that means is basically we can set P is equal to this statement right here, the capital of North Carolina is Raleigh. You can kind of put quotes around it. That's what normal people do. And then you say, what is the truth value of P? I'm sorry, this is of value of P. and you can say it's true. And that would be the answer for the problem. And you'll sometimes see P here, you'll sometimes see Q, sometimes you'll see R. So it does not matter at all. You can also, this is another thing. This is an operator. One operator we learn is the not operator. So if, say, you see P right there, like an example would be not P. Basically, this means it is not the case. So say P is equal to the capital of in North Carolina is Raleigh. If we do not P, this is equal to it is not the case that the capital of NC is Raleigh. So you just add it is not the case, or you basically negate the whole thing. So that's an operator. Let's see. There's also something called connective. Let's see. Let's go to another page. So connectives are operators that combine two propositions. So examples of these are the AND operator, the OR operator, exclusive OR operator, and the if-then operator. So we'll look at that in a second. So an example of this would be, example would be P and Q. So if P is equal to, let's see, I have a dog, and Q is equal to I have a cat. Remember, Q and P are propositional variables, right? And a propositional statement, which P and Q represent, are either true or false. So I have a dog could be true or false. I have a cat could be true or false. And on these propositional statements, we can use these operators, right? We learned about the not operator, and they're also operators. However, they combine two propositions, like slash propositional variables, which are kind of basically the same thing because they represent a proposition. So we could say P and Q. If P and Q are equal to these two propositions, then the statement P and Q is equal to I have a dog and I have a cat. So let's see. So this is equal to and, this is equal to or. So I have a cat or I have a dog. This is the exclusive or, which is kind of tricky, but exclusive or. You wouldn't actually write exclusive or in there, but you would. It basically, I'll show you in 1 second. So each one of these operators has a table that can easily be understood. So the let's make a truth table. This is a table, and let's see, P, Q, true, true, false, false, and then true, false, true, false. So with an AND operator, P and Q. Whenever you have trues, it's true. If there's any falses, it's always going to be false. Since there's a false, 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 but there's both trues. With an OR, your true table is going to be P, Q, true, true, false, false, true. So whenever you have one true, it's going to be true. So since there's one T in there, it's going to be true. Since there's one T in here, it's going to be true. Since there's one T in here, this can be true. Since there's no T's in here, it's going to be false. And let's see that, and then exclusive OR is when you just look up an example of that online, but P of how you would write it out as a propositional statement, but P or Q, if it's true, true. This is a T, true, false. Whenever there's two the same, then it's a false. And when they're different, it's a true. And that's the truth table. So when you have, when two of the statements are true, it's going to give you a true statement. When there's a true statement and a false statement, it's going to be false, the entire statement. So example on OR, let's see, or let's do example on AND. With I have a dog is P, Q equals I have a cat. So if we say this one is, let's see, if this one is false and this one is true, then you can look here, true, false, then the entire statement P and Q is false because you kind of just read it over. And you can kind of memorize these truth tables. It kind of is easy to think about. My thing was out here. Exclusive OR, sorry about that. When they're both covered, when they're both trues or both falses, it's false. When it's different, it's true. That's exclusive OR. That's the truth table there. Sorry, I wrote it out of the screen. And that's kind of it there. These are truth tables. These are operators, and we're kind of just learning about logical operators and propositional logic. So that's that. There's one more quick thing. I only have 2 more minutes left. I can't go over 15 minutes, but there's also an operator. It's actually operator. It's actually a connective, because we learned about if the operator combines 2 different propositional variables, it's a connective, so it's combining 2 different ones right there. This means if P, then Q. Let's see, this just basically, you can also say P implies Q. There's just different ways you can restate this one little statement here. If you're looking at the truth table of if P and Q, it would be it's true, false, and then P and Q is only false when it's a true or false, and the rest are true. So when you have 2 statements, I have a dog, I have a cat, this is P, and this is Q. If I have a dog, then I have a cat. Okay, that's it. Like, subscribe, and share. Thank you. Bye.